This is a welcome video for Everyday Physics for summer session in 2014-2015. So this video is just going to cover what you can expect from the course, how much work you're going to have to put in, and how the course runs.
Hello and welcome to Everyday Physics. I'm Elizabeth Anksman and I'm the lecturer for this course. I'm the first year director in the School of Physics. So in this course, we're going to get you to look at the physics behind lots of everyday phenomena. It's hoped that after doing this course, you'll never look at the world the same way again. You'll be like, oh, but how does that work? I know how that works. And so this course has no university prerequisites. We do assume that you've done high school science up to the year 10 level and also mathematics. So this course does not cover calculus, you don't need any calculus, but you do need some algebra, so rearranging formulas, etc., some trigonometry, just with right angle triangles, so you need to know about SOHCAHTOA. And you will need a little bit of geometry as well. So if you're rusty on some of these topics, you may want to spend some time now revising them. There will be links underneath the lectures where these things come up to the Khan Academy if you do need a bit of revision of some of this maths. So in this course, we're going to cover 12 topics. We'll be looking at how 12 different things work. So in this summer session version of the course, it's quite condensed. We're going to be doing 3 of these topics each fortnight. So that will be quite a lot of work, just a warning. So how it's going to work is each topic's going to look at the everyday phenomena and or an everyday device and the physics behind this. So for example, we'll start with streetlights. And with streetlights, we'll be looking at electric current, we'll be looking at power, and we'll also be looking at the photoelectric effect, which is kind of exciting because it was some of the first evidence of quantum mechanics. And streetlights actually use the photoelectric effect to determine when they should turn on. So with each of these topics, you're going to be provided with approximately 5 to 7 videos, which are equivalent to lectures. So these videos will cover the theory behind it, they'll look at relevant demonstrations, and then there'll be worked examples as well, showing you how to use these formulas. After that, you're going to have approximately 10 tutorial problems. So I highly recommend that you try working through these tutorial problems on your own. There's lots of educational research that shows that the best way to learn physics, actually the best way to learn almost anything, is to practice solving problems yourself. So have a look at the tutorial problems. They're all as a PDF. Print them off or read them on your screen. Have a go at them. And then for each of these tutorial sets, there is a video which shows you step by step how to solve all the problems in the tutorial sheets. But try them yourself before watching that video. Now in this course, self-motivation is key. No one is going to check that you have done those tutorial problems. However, if you want to get the most out of this course, if you want to really end up understanding the physics, then you should be trying these tutorial problems yourself. Now, because physics is an experimental science, we have 6 investigations along the way. So these investigations, we've tried to make them possible with common household equipment. So there's a list in the course outline of all the equipment that you're going to need. You may want to start gathering this equipment together now. If you're in Sydney and you're having difficulty sourcing some of the equipment, like say you don't have a set of electronic scales for use in the kitchen, then you can borrow the equipment on 24-hour loans from the first year physics laboratory. So if you just go to the lab staff there, tell them that you're doing everyday physics, they'll get you to sign something and they'll lend you the equipment that you need for the investigation. But we do have limited sets of this, so it's for 24-hour loans and you can then return it so that other students can borrow it if they need to. So with this course, you'll be encouraged to check stuff out along the way. Because physics is an experimental science, you should not be trusting me that everything I tell you is actually correct. You actually need to go and test it for yourself. So along the way in lectures, where appropriate, we do suggest little tiny experiments that you can do at home just to verify that what I'm telling you actually does happen. So the first of these investigations that you're going to have to do is going to involve measuring the specific heat of water with a kettle. So for this one, you're going to need a kettle, stopwatch, a measuring jug, some water, and a thermometer is optional. So as we said, there's going to be 6 of these investigations along the way. There'll be one every approximately 2 topics. So each of these is worth 5%, giving you a total of 30% of your marks for the course. You're going to submit them as a report through Turnitin. Your tutor will then mark them and give you feedback. It's highly recommended that you look at the feedback that your tutor gives you before submitting the next investigation, so that if you made a mistake or did something not quite as well as you could have in the first investigation, you've learnt from that and you don't make the same mistake in the second investigation. So all this feedback and comments can be accessed through Turnitin. If you have any difficulty accessing that or any other parts of this course, then just email me or post up on the forum. Best to post up on the forum because other students are probably experiencing similar difficulties, so that you know where all this stuff can be found. Now, every fortnight in this course, you're going to have an online test. So these online tests are each worth 10%, so there's 4 of them because they're fortnightly and it runs for 8 weeks, giving 40% of your final mark. Now, you'll have approximately a week to do these tests. You can look in the course outline to see exactly when they will be released and when they're due. Be warned, these online tests, because it's all open book, they are fairly hard. This is because we do need to distinguish between high distinction, distinction, credit and pass students. There is no final exam for this course, and so we try to use these online tests to distinguish between different levels of performance. It's not possible to get an extension on any of these online tests, because as soon as that test shuts down in Moodle, you're able to access the answers, see what the correct answer was, and we also release solutions showing you how to solve all of the problems. Now, the final component of your assessment is really the most interesting part. It's a final report. Now, in this final report, what you need to do is choose one phenomenon that interests you. So if you're interested in sport, you may want to look at a particular sport. If you love sailing, then maybe sailing. Or if you love music, then maybe look at how a musical instrument works. So you'll want to be looking at one of these phenomenons or devices and then working out the physics behind it. You'll then need to construct an investigation, like the investigations you've been doing through the course, to investigate the physics. So there's guidelines on suitable topics to choose on the Moodle page, and I also encourage you to post up on your group discussion forum your topic so that you can get some feedback from the tutor. So what you're going to need to do with this is, hopefully a few weeks into the course, you'll come up with a topic and start working on this topic on your own. You'll then need to submit a draft report for peer review. So you'll need to submit this on Moodle through the peer review tool. And it's really, really important with this one to submit it by the deadline, because of how the peer review works, it's not possible to get extensions. So you submit your draft report for peer review. You'll then be looking at 5 other students' draft reports and giving them some feedback, and they'll be looking at yours and giving you some feedback. So 10% of your mark is actually going to come from the quality of the feedback that you give other students. So you're trying to help other students improve their report, and they're trying to help you improve yours. So you have approximately a week to do that. All the dates are in the course outline. And then you'll get the feedback, and you'll have a little bit of time to update your final report from your draft report before you submit it to your tutor for marking. So your final report is worth 20% of your final mark, and you'll need to submit that through Turnitin on Moodle. Okay, so just a warning with this course. This course is an online course. This means it's online. It does not mean that it's an easier course or that there's less work in this course than in a normal 6-unit of credit course. This course is Phys 1110, and that physics code means something. So this is an introductory physics course. It teaches physics at around about the same level as our face-to-face course, Fundamentals of Physics, which is Phys 1111. So you are allowed to elect to do this course as a Gen Ed, but it appears on your transcript with a physics code, and the level of work involved is equivalent to other first-year physics courses. So just to give you an idea about how much time you should plan on spending in this course, it's pretty much the same level of physics as the Fundamentals of Physics course. In that course, during sessions, so over 12 weeks, the students have 3 hours of lectures each week, a 2-hour lab session and 1 hour of tutorials. So that's 6 hours face-to-face, and we expect them to put in a similar amount of time out of class. So that's 12 hours per week during session. Now in summer, we've condensed everything. Instead of 12 weeks, it's now 8 weeks. And so that would work out as, rather than the 12 hours per week, that would be 18 hours per week. So if you put 18 hours per week into this course, you'll do really well and you will get a lot out of it. So 18 hours per week would mean putting aside about 2 days per week to work on this course material. So clearly, because it's online, you're going to need to be self-motivated to do this, but I recommend now that you start planning on spending that amount of time on it. Now, under each lecture, there are readings provided. These are optional. They're there to supplement it. So if there's something that you didn't understand in the lecture, then you can post about it on the forum and get some help, or you can have a look at these readings. The readings, some of the readings also contain extra practice questions. So if you're wanting more practice questions than the 10 tutorial problems each week, you can often find some extra practice questions in these readings. So there's no prescribed textbook for this course, but there is readings associated with each of the topics, and you can access that free of charge from the library. Now, another few things to note: because this is running in summer, it's quite likely that a few of you are doing the course from overseas. Please note that all the submission times in this course are Sydney time, so you need to take that into account if you're overseas. Make sure that you know what the time is in Sydney so that you don't miss any of these deadlines. The easiest way to lose marks in this course is not to submit your work on time. The penalties are quite steep for not submitting work on time. For the investigations and the final report, it's 25% per day. With the draft report, you cannot submit that late, and the quizzes cannot be submitted late. The reason for this is that the tutors need to mark it and give you feedback before your next assessment is due. So it takes the tutors a little while to mark it, and we need to ensure that all these are submitted so that the tutors can mark it, give you feedback so that you can react to that feedback before the next lot of assessment is due. So I recommend that you print out when everything's due. It's all in a table on the course outline. Stick it on your wall and just keep on referring to it so that you don't miss any of the deadlines through the course. You can even submit everything early if you want to. It's just you don't submit it late. The other thing that you need to avoid is plagiarism. There's lots of links on the Moodle page to describe what plagiarism is. Submitting other students' work for your final report is plagiarism. Submitting work which somebody else did in another course is plagiarism. Submitting work for one of the investigations and then submitting it again for the final report is plagiarism. So make sure that you know what plagiarism is, and please don't do it, because it takes me a lot of time, it takes you a lot of time, you get a big red cross on your academic transcript about it. So please just don't do it. If you don't have time to do an assessment, then don't submit anything. That's better than submitting somebody else's work and pretending that it's your own. So I do hope that you enjoy this course, and I really hope that it makes you see the world in a different way. It's a good idea to start thinking now about what you may like to do for your final report. There's lots of information about this on Moodle. What I'm going to do now is use a screen capture program to show you how to navigate the course so that you can make sure that you don't miss out on any of the resources which are here on the Moodle page. So just before we go to the screen capture part and I show you the Moodle site, I'd like to introduce Seb Fricker to you. He'll be covering for me a bit over the summer because I'll be going on maternity leave. So we'll let you know when that occurs, and at that point he'll start answering posts on the discussion forums and things. Some of you will be lucky enough to have Seb as a tutor for if you're in Group D for this course. So here's Seb, just to introduce himself.
Hi, I hope you will enjoy the course, and I will do my best to make it a really smooth course for all of you. If you've got any questions, please contact me and I will do my best to answer everything. Enjoy.
Now, when you log into the Moodle site for this course, it should look something like this. At the top, you're going to have a list of what's due over the next 3 weeks and what you should be doing. So if you're watching this before the course starts, you'll see week 0 here, but you will have access to some of the videos, but the course hasn't actually started yet. Then the course actually starts on the 1st of December, and in this first week, it's good for you to watch the video lectures and try the tutorial problems. So we'll look at how to access those in a little minute. Then in week 2, you can see you need to finish watching the video lectures and the tutorial problems for the first 3 topics. You'll also have access to quiz 1, and investigation 1 is due on Sunday at the end of this week at 9 p.m. So you'll always have access to this important course information. So here you can download the course outline. Now I highly recommend that you look at this in detail because it sets out all the assessment requirements, and there is a very useful page right here which outlines when all the assessment is due. So I recommend that you print this out and stick it on your wall so that you remember about it and that you don't miss any of these deadlines. Now below that's the syllabus, which just covers the topics that we'll be covering. So this covers all the topics that you'll need to learn about if you want to sit the GAMSAT exam, but we take a more phenomenological approach. So we start looking at an everyday object or phenomenon, and then we look at the physics behind that to make it a bit more interesting. You've got a data sheet here which will just gives you the values of some of the constants, so you may find this useful for some of the quizzes, or this data can just be found on the internet through a quick search anyway, so whichever method you prefer to get those constants. Now there's plagiarism notes here. I'm sure you all know what plagiarism is. A few students in the past have plagiarized this course. Please make sure that you don't submit plagiarized documents because we do take it very seriously. The welcome video, which presumably you've found because you're currently watching. Now here you've got information about the final report. So the final report isn't due till the end of the course, but you will be submitting a draft of your final report a few weeks before the end. So all the dates and details about that final report can be found here, and you've got a rubric to tell you exactly how that final report's going to be assessed. So you're going to assess the work of 5 of your peers. The marks you give your peers don't actually count towards their final grade. You're actually marked on the comments and the quality of the feedback you give them. So when you're doing that, you want to be as insightful as possible and really help your peer along as much as you possibly can. Now, this is where you will be submitting that draft report. But if you're interested, you can have a look at some of these reports to give you an idea of what's expected. These reports aren't perfect. They're far from perfect, so they wouldn't score especially highly, but you can open them up and have a look at them to see what is actually expected of you. So below that you have a group discussion forum. You'll be assigned to a group with a tutor, possibly not until the 1st or 2nd week of the course. This is where you can introduce yourself and you can ask questions about your final report. So your tutor's going to help you with that final report. When you've got an idea about what you want to do, you can post it up there and your tutor will get back to you over whether that's a good idea or not. Now each topic has a set of video lectures, tutorial problems and a discussion forum. Some of them also have investigations associated with them, and every 3 topics there will be a quiz. So when that's available, it'll pop up here in topic 3, in topic 6, 9 and 12. So to do this course, you've got books of the lecture notes. So you can see down the left-hand column here, there's all these different topics, and there's a video which currently hosted on YouTube about that topic. Now, down below each video, you've got a summary of the equations covered and also some readings in case you want to find out a bit more. So these readings aren't compulsory, it's just some people like to see it in written format as well as in video format. So watch these videos, and if you want to, have a look at the readings. Now what's really, really important is that you try these tutorial problems. So for each topic, you'll have a set of approximately 10 tutorial problems to try. So trying these will help get you ready for that quiz. Now, if you get stuck on any of these problems, there are solutions. So there's a video which goes over the solutions of each of those problems. But it's really important that you try the problems yourself first, because you learn physics by doing, not by watching me doing. So have a go at the problems, and then when you get stuck, you can have a look at these solutions. And if you still don't understand something, or if you spot a mistake, which hopefully you won't, you can post about it on this discussion forum. So each topic has its own discussion forum, and myself or Seb will get back to you very quickly if you post something on these discussion forums. So you have access to Investigation 1. So we've provided it in 2 formats, as a PDF and as a Word document, because you may want to use the Word document to complete the tables and stuff. It's kind of well laid out there. So it's fine to use that as a template for your report if you want to. Now we've provided a couple of plotting templates. You'll probably want to use the linear plot with errors template if you want to get the highest mark you can for your report. So you can either use that, it's an Excel template, so you would need Excel, or there's lots of graphing programs on the internet that you can use to graph your data. Now we've got a cover sheet here. You don't need to use the cover sheet unless you're submitting a handwritten report, in which case attach the cover sheet but don't fill the cover sheet in. Turnitin won't accept material which it can't recognize enough typeface on, so attaching this cover sheet is a way of forcing Turnitin to recognize your document and accept it. And then there's a link here to the Khan Academy covering graphing straight lines in case you've forgotten how to do that, and details about how to rate risks here, as it's really important that you stay safe doing this course. So for all of the investigations, you'll either need to include a statement that you followed the reduction of risk things that we've outlined, or you'll need to rate the risks yourself and suggest ways to minimize these risks. So all the investigations are safe and you should not hurt yourself as long as you follow the recommendations for the reducing the risks. So then when you've completed the assignment, you'll submit it through Turnitin by clicking on that link there. And throughout this course, you'll be using uncertainties in your data. So we have some extra videos here about how to deal with uncertainties. So if you don't know much about dealing with uncertainties, you may find some of these videos useful for you. Okay, so that's the layout of the course. If you've got any questions about where to find anything, just post them up on any of these topic discussion forums so that I can get back to you. I hope you enjoy this course.